Hey guys, today we're going to solve some inequalities, and these are not that bad. They actually work just like equations. And so if I were to summarize into three basic steps, you want to simplify both sides. And usually this involves maybe distributing, maybe combining some like terms. Two, you're going to move variables to one side and then numbers to the other. And then third, we can always use inverses to isolate our variable. And that's usually the very last thing we do. And a common thing is, especially in a problem like this, where I have some amount of x's, I'm always going to divide in that last step. And we call that the division property of equality because we do it to both sides. So it's a little bit weird, but if it helps you, you can always pretend that this says equals and just think what you would do. But you have to be a little bit careful with that because there is one special rule with inequalities, and that is this direction will change to greater than or equal to if I divide or multiply both sides by a negative number. Again, I'll just sort of pretend that that says equals for now. I know that I have some like terms here. 7 and 9, that's a negative 9, is going to give me negative 2x. I could call that negative 2x plus 12, or 12 minus 2x is actually perfectly okay as well. Either one will get me there. I kind of prefer to put my variable first, so I'm going to go ahead and erase the second one. Now that I'm here, the left side is simplified, the right side is simplified. So this is probably the step where I need to start moving my numbers to one side. I already have a number over here, so why not move this other number with it? To get rid of the 12, I do the inverse of minusing 12 from both sides. And I'll have negative 2x is equal to negative 4. Now, a lot of people, less than or equal to negative 4. A lot of people see that and they're like, oh, negative, right? I'm going to flip the sign. Be very careful here. We're not flipping it because I haven't multiplied or divided yet. And remember, the whole point about dividing or multiplying by negative is that I'm going from the positives to the negatives or the negatives to the positives. So what was larger is now smaller and what's smaller is now larger. When I'm just subtracting, I haven't really done that yet. I know I ended up with a negative here, but that's okay. I haven't really changed the essence of what's going on in this problem. But I do have one last step where that will happen. I have to actually divide by negative 2. And since I'm divided by a negative, I will go ahead and change this to a greater than sign. And this will now be x is greater than or equal to 2. And if you kind of think back to this, that actually makes a lot of sense here because if I picked a number that was greater than 2, like 3, for example, and I plug it back in here to this step, that would give me negative 6. And negative 6 is indeed less than or equal to negative 4 because larger numbers in the negatives are actually smaller. Negative 6, although it has a larger amount, it's still technically smaller than negative 4 because it's further to the left. If I hadn't reversed the sign and I had left it as x is less than 2, then that would give me something that just isn't true. Like, for example, 1 would be a solution to that. 1 is less than 2, right? But if I plug that back in here, that doesn't make any sense because I'll get a statement like negative 2 is less than or equal to negative 4. And it's true in the sense that like 2 is a smaller number than 4, but unfortunately, again, once I'm in the negatives, that's not true because negative 4 is further to the left. So you have to be very careful. Only flip the sign when you multiply or divide by a negative. But in this case, if you can follow those basic steps, you got it. And that is a lot of what's on the test this week. Good luck.